if we talk to any state, it's a lot of bridges that they want to do these type of activities on them, but the problem is always that there's not enough funding. In order to address this, we have to make sure that the money that we spend on these bridges, the way we choose them are, we choose the best possible bridges to do these preservation activities on them, so to optimize our budgeting. In order to do that, we need to make sure we have accurate data, and accurate data comes from the inspection and the way we do the analysis to come up with which bridges are optimized for doing preservation on them. So the goal of our company to come up with this product, InspectX, is to make the process of inspection more efficient and also make it easier to make the data more accurate and essentially in long term save money for bridge owners. I'll give you a background, quick background on the element level inspection, how it came to being. So in 1993, FHWA created a task force charged with the development of core elements. And in 1995, T18, AASHTO T18 adopted the model, the core element model. In 2010, they changed it, as I assume most of you know, to the new element model, which is NBE, BME, and ADE, and now it has 4 condition state, and they removed the smart flags. And in 2015, FHWA required all the states to submit not only their MBI data, but also the element level inspection data for all the bridges that are located on the NHS. Some of the advantages of the element level data is that it's more detailed, it's much more detailed than the MBI deck superstructure, substructure condition. It helps us to develop better deterioration modeling, gives us a more better picture into what's going on with the bridge, and essentially we can develop better performance measure. So currently this is based on last year AASHTO survey. About 3/4 of the states are actually doing element level inspection on older bridges, not just the ones that are on NHS. And about 20% of those states are doing more than, doing all the NHS bridges, but somewhat more than that. And 7% of those states are only doing the element level inspection on the NHS. What's the current practice that states are doing their inspection? Most of the states currently, what they do, they go with paper forms and cameras to the bridges, and they have the manuals and the previous inspection reports. That's how most states do it right now. Challenges and problems with that method is that inspectors usually have to, element level inspection is relatively new. Inspectors are not 100% familiar with it. So they usually carry a big inspection manual with them, AASHTO manual with them, and also all the previous reports. Then said that, for example, the HoloLens guy, they had the previous images and all of those. So if we have an electronic solution, we don't need that, as the HoloLens thing enabled the guy. And then photos, we save them currently on the camera. We have a photo log, and we have to go back to the office and kind of link these photos to the notes and defects. And a lot of extra time is required to manually enter all the data to the BMS, being BRM or InspectTech or whatever BMS system they're using. Couple other is that it's not a very efficient process, and we don't record the location of the defect in a sense that we can query that data later on and know what's the location. And when I say location, for example, which girder it is, in which span it is, which part of the girder the defect is located. So our solution for this is InspectX, which is an integrated bridge inspection platform. Some of the features that I wanted to point out is that it's a mobile bridge inspection. Is based on the tablet, and it doesn't matter which platform. If you're using iPad or Android or Windows tablet, it works with any tablet. It has the state-of-the-art 3D visualization, makes the inspection a little bit more sexy. The defects are recorded with their location, and the photos are attached to them. It's very simple to review the process. It's much more simple because you can see the data all in one place and more effective. It's automatically we can sync with the data with the current BMS system, so it's integrated with BRM. And when we go to the bridge to do the inspection, we can do offline or online inspection. Usually there is no internet connection on the bridge, so you can use the offline inspection on the offline mode of the tablet. And then essentially it improves the QA/QC process. So just a short schematic how the system works. So this is the InspectX server. So you add the data to your tablet, being iPad, Android, Windows tablet. The inspector adds the data for that certain bridge to the tablet before going to the field. They do the inspection with the tablet, and then the data goes back to the server, and then the server talks to the BMS system in the agency. I put just a couple of screenshots of the system. You're more than welcome to stop by the booth so we can give you a live demo, but these are a few screenshots of the system. This is before going to the inspection in the field, in the office. You want to see the information of the bridge, and then you can add it to, the inspector, they can add it to their working set so they can do offline inspection of the bridge. And these are a few screenshots of the actual inspection. On the top left, you see, for example, this is the NBE section of the inspection. You see all the NBE elements of the bridge you're inspecting. You can add notes and defects, and whatever you want to do, the system is designed to walk the inspector through everything. So for example, window you see it wants to add a defect for element 205, which is reinforced concrete deck. So it tells the inspector, these are the defects that AASHTO has defined for this type of element. And when they click on any of the condition state, it tells them what's the description of that condition state. So it makes it much easier for the inspector to do their job, and it makes it harder for them to make mistakes. And we have a lot of validation in place. So essentially it makes it much harder for them to put wrong data. And they can add photos and comments for the inspection. And as I said, there is a 3D modeling there as well. And this is not CAD accuracy 3D modeling. This is just basically the first time we get some geometrical information for the bridge. We create this 3D model, and the inspector can use this 3D model to record the data. They don't have to use the form. So they just click on the different elements and click on add defects, for example, and then it walks them through. At the end, it says, okay, just drop it where you can drag and drop the defect on the right location. So this can be a really powerful visual tool that for asset management. When I go back to the office, it's so hard for us humans to read to see a bunch of text and get a good idea. But this visually gives you a very good idea what's the condition of the bridge. And next time you want to go do the inspection, you don't have to start from scratch. You know all the defects, and you can go through them, modify them, delete them, add new defects. The benefits to the inspector, some of them that are listed here, is a very user-friendly application. The learning curve for the element level inspection is relatively high, and it lowers that. The time of the inspection in the field, and especially back in the office, will be significantly reduced. The accuracy of the data will be improved, and then there's no need for redundant data entries. And multiple benefits to the state agencies too. So it maximizes the efficiency of the inspection forces. It reduces the inspection and training costs. The platform is a more efficient, gives a more efficient reviewing process. They can effectively monitor the bridge deterioration as it's going on. Everything is digitally stored in a one database, all the defects, images, notes. It can integrate with the BMS system and get the data from it and puts the data. So for example, when you do the inspection and come back to the office, it can automatically transfer all the images, notes, and defects and quantities to your BRM system, for example. And it makes it the deterioration modeling that we have right now. If we add all these accurate data, feed the accurate data with all the location data that we have, with this system, it makes it much more accurate, the distribution modeling we get. So with this system, you can easily, visually see how this progression in place.
This 3D model, you have to create that model, or with photograph you can automatically get it?
So the 3D model, we have a form, and if you have the data, it takes 2 to 5 minutes to fill out the form one time. The reason we cannot do it with the photo, because the form asks for all the elements. The photo, it doesn't tell you if it's a deck, it's element 12 or 13 or 15. So we need that information. But it's a very basic form. It asks for all the elements, and also, for example, how many girders you have, what type of superstructure you have, how many columns or pile you have, if it's a pier wall, so those type of configuration.
It also covers NBI data also?
It covers all the NBI data.
And clearances?
Yeah, so we can show you. So we have different sections on the app. So there's an inventory section. You can see all the NBI information from the previous inspection and put the new information, all the NBI condition data, and also all the, do element level inspection.
Can we take a 3D, can we create a 3D model for clearances?
As it is right now, no, but that's not a hard thing to do.
In the 3D view, does it differentiate between the top of deck and the bottom of deck, and you have separate defects?
Yeah, so currently what it is, when you add a defect to the top of the deck, you see it on the bottom of the deck as well. Some agencies are different. So for example, they do top of the deck separate from the bottom of the deck. So that's something that we can easily put for that certain agency to do it like that. So yeah, it's customizable, and easily we can do all of those things.
I'm involved with bridge load rating. Can this data be used to populate fields in the AASHTO-AWARE bridge rating program?
Data, we are integrated with BRM. I haven't looked into the load rating software of the AASHTO. If they have APIs, it's very easy to integrate that with that software.
Thank you.
You can verify this, but I assume it would add up the condition states, the square footages and linear feet of 1, 2, 3, and 4. But is it intelligent enough to avoid overlapping or reduce overlapping defects?
Yeah, exactly. So for example, for deck, if you add a defect that is condition state 2, then add another defect that is condition state 3, and they have some overlap, you can only see the overlapping part with the condition state 3, and then when it's calculating the conditions, it knows that overlapping area, it only calculates for condition state 3. It doesn't double calculate it if you're using the 3D model.
When the state puts this out to let on a job, and
I'm sorry?
When the state lets a job, and they have this kind of information, who can access this? Say a contractor's bidding it and they want to look at the conditions of the bridge. Would it be available? Can they put that out, or is anybody available to get in there?
So basically the way we have it right now, we have different access roles. We have a view-only access roles, and if, for example, the state is using the system, it's up to them. They can easily give you that access if they want. It's up to them. So they have the means to do that. But at the end of the day, it's something that they have to decide.
Is it configurable? In other words, if the state has its own specific inventory elements or items, am I going back to you to program them into code it into the software, or is there something can I create specific inspections or fields?
For the 3D model?
No, say I want to add, I have an element that's a state element. It's not an AASHTO. It's something that I want to keep track of.
We have a section for states to go through, and they can add their agency-defined elements, and they can also define the defects for those agency-defined elements.
Okay.
And that's the only thing. Then once it's there, then it's state by state. So they can, as a state, you can go and define your ADs there. Thank you.
The preceding video was produced by the National Center for Pavement Preservation. More information can be found at tsp2.org. That's tsp2.org. Additional support provided by Michigan State University.